Hello everyone, it's good to have you back on Step by Step Academy. My name is Aki. In today's video, you and me together we will learn about simple equations involving module arithmetic. At the end of this lesson, you should be able to solve any simple equation in any given mode. Also, I would like to encourage you to look around this channel. You will find similar videos on introductory lessons to module arithmetic, addition, subtraction, multiplication, and division of module arithmetic. You will also find videos on simplification and multiplicative inverse in module arithmetic. If you like the content of my channel, please do consider subscribing so that you'll be notified whenever I post similar content. Alright, without wasting much time, let's begin right away with the following examples. Number 1, we have 3n is congruent to 5 mod 7. Now, to solve this in normal algebra, what we would have done is to divide both sides by 3. But at the moment, this 5 is not divisible by 3. So what do? What we'll do is to look for multiples of 7, is to keep adding multiples of 7 to 5, so that 5 can now become divisible by 3. Multiples of 7 include 7, 14, 21, and so on. So if I add 7, the first multiple of 7, if I add that to 5, that will give me 3n is congruent to 7 plus 5 mod 7. Now this will give us 3n is congruent to 12 mod 7. So now we can now divide both sides by 3. If we divide both sides by 3, so n will be equal to 4 mod 7. So this will be our solution for n. Apart from this solution, there are other solutions that will exist for n, because for the lowest possible solution, other solutions will include 11, 18, 25, and so on. To generate other possible solution, we just keep adding 7 to the first solution, which is 4. 7 plus 4 will give us 11. 7 plus 11 will give us 18. 7 plus 18 will give us 25, and on like that. So the possible solution for n for this equation 3n equals 5 mod 7 is 4, 11, 18, and so on. Number 2, we have 3n is congruent to 2 in mod 6. Alright, to solve this again, 3 is not divisible by 2, so we keep adding multiples of 6 to 2 until we get a number divisible by 3. So the first multiple of 6 is 6, the next one is 12, 18, 24, and so on. Now if you look at this, no matter the multiple of 6 that we add to 2, we will never get a number divisible by 3. For instance, if I add 6 plus 2, that will give me 8. 8 is not divisible by 3. If I add 12 to 2, that will give me 14. 14 is not divisible by 3. If I add 18 to 2, that will give me 20. 20 is not divisible by 3. And if I add 24 to 2, that will give me 26, which is also not divisible by 3. So for this problem, there will be no solution. There's no solution for n in this particular problem. And the reason for that is because 6 rather, is a multiple of 2, or 2 is divisible by 6. Whenever we have such questions as this, where the remainder or the residue here is divisible by the mod, then there will be no solution. Number 3, x plus 5 is congruent to 2 in mod 7. Now to solve this, we collect like terms. 5 and 2 here are like terms, so take plus 5 over to the other side. We have minus 5 plus 2 mod 7. Now minus 5 plus 2 will give us minus 3 mod 7. Minus 3 mod 7. Again, look for multiple of 7, because we can't leave our answer as a negative. The reason is because negative 3 is not a residue in mode 7. Negative 3 is not a residue in mode 7. So what do? We look for multiples of 7 such that when we add to this, it will turn this into a positive number. So we have 7, we can also add 14 and so on and so forth. So x will be equal to or congruent to 7 minus 3. So I'm using the lowest multiple of 7, which is 7. 7 minus 3 mod 7. So my answer to this question will be 4 mod 7. Again, other possible solution will be 11, 18 and so on and so forth, just like we have in the first example. Now for question 4, we have 2n plus 4 is congruent to 5 in mod 7. Again, collect like terms. 2n will be congruent to take the positive 4 to the right. That will be negative 4 plus 5 mod 7. Then 2n is congruent to 1 mod 7. Again, here 1 is not divisible by 2. So what do? Again, we look for multiples of 7 such that when we add to 1 that we have here, the 1 will become divisible by 2. So multiples of 7 again are 7, 14, 21 and so on. So again, I'm using the lowest multiple of 7. That will give me 2n is congruent to 7 plus 1 mod 7. So 7 plus 1 will give me 8. So I'm going to have 8 mod 7. Therefore, divide both sides by 2 again. We will have n is equal to 4 mod 7. So again, our solution to this problem is n is equal to 4. Another possible solutions would be 4 plus 7, that's 11, 18 and so on. Now, for question number 5, you have 2x plus 2 is equal to 4 mod 5. Again, we collect like terms here. This will be 2x equals to 4 minus 2 in mod 5. So this is 2x is equal to 2 mod 5. So here we can divide both sides by 2, and therefore we have x is equal to 1 mod 5. So other possible solution for x will include 1, 6, 11, 16 and so on. Just keep adding 5 to the initial solution 1. Alright, so I'll leave you to solve the question number 6. Why post your answers in the comment section below when you are done. So this is how you solve simple equations involving module arithmetic. Thank you for your time, and please consider subscribing to this channel. I'll see you in the next video.